Welcome back to CS4540 Week 8 video. For this week, we have 6 clips. First clip with Christopher Manning with R1 reasoning. Second clip is Christopher Manning, how much understanding and intelligence. Third clip is Noah Brown, reasoning. Fourth clip is Can AI think IBM token bias? Fifth clip is Can AI think IBM chain of thought prompting? And lastly, we have graphics in 5 minutes with reinforcement learning AlphaGo.
That for all of these abilities, it still seems like we've sort of got something more like a simulacrum that sort of lays down text based on all the text it's written of the kind of patterns it's going to use. And it doesn't necessarily really understand things deeply. And you see some signs of that even when it goofs a little, right? That it said correctly the condition that the middle digits had to add to 11, but then suddenly it puts down two numbers that don't add to 11, and then it corrects itself and goes back. I mean, it's very complex. But I mean, I really do feel that somewhere along the line, we still need a model with more of a world model than these current large language models have, because, you know, no matter how clever they are, there still are these models that are sort of producing long strings of text tokens rather than having sort of any kind of joint model of the world. But, you know, that's really hard to notice.
This clip that I have highlighted underscores a fascinating paradox in the behavior of large language models. They can articulate a correct reasoning process yet arrive at an incorrect conclusion. This phenomenon is deeply rooted in how these models function. LLMs generate text by predicting the next token in a sequence, relying on patterns learned from vast datasets. The, this token by token generation means that while a model might produce a sequence of tokens that mirrors logical reasoning, it doesn't truly understand the context in a human sense. Consequently, even after presenting a logically sound rationale, the model might conclude with a incorrect answer due to misaligned token predictions or overfitting to certain patterns. This behavior has been observed in various studies. For instance, research indicates that longer chains of thought don't necessarily enhance accuracy. In some cases, they might even introduce errors. Additionally, models can be misled by manipulating ending tokens, causing them to disregard correct reasoning steps and produce wrong results. This clip serves as a compelling illustration of the limitations of current AI models. It highlights the need for continued research into improving the alignment between a model's reasoning process and its final outputs. Understanding and addressing these discrepancies is crucial for developing more reliable and trustworthy AI systems.
Say, dear large language model, pretend you are Warren Buffett and tell me what stocks I should invest in. And it will, but that doesn't actually mean you're getting good investment advice. But, you know, conversely, you can go to the other extreme and assume that they're good for nothing. And that's a huge mistake. I mean, these large language models are just amazing in their abilities. They're better at absolutely everything that has been explored in natural language processing and knowledge representation and reasoning over the past 60 years. So they can be used to increase your productivity, to learn new knowledge in all sorts of ways. And they give huge order of magnitude gains versus many other technologies that have been worked on. So I encourage, for any of you that are more on the humanities side of things and haven't been keeping up with, say,
Completely agree with what Christopher is saying about the role of AI in learning. Personally, I've used AI a lot, not just for schoolwork, but for all kinds of things in my life, whether it's helping me break down complicated topics in computer science or even guiding me through real life decisions. AI has made it so much easier to find answers and actually understand what I'm doing. What stands out to me is how Christopher frames AI as a tool that empowers us, not replace us. That really resonated with me because AI doesn't do the work for you. It helps you figure things out for yourself. And in that process, I've learned faster and more deeply than I would have just Googling or reading a textbook alone. It's like having a super helpful tutor available 24/7, but one that doesn't judge or get tired. This clip captures the potential perfectly. It shows how, when used right, AI isn't just some fancy new tech, it's a real meaningful way to grow and learn.
And the results that I got blew me away. It turned out that having the bot think for just 20 seconds in a hand of poker got the same boost in performance as scaling up the model by 100,000x and training it for 100,000 times longer. Let me say that again. Spending 20 seconds thinking in a hand of poker got the same boost in performance as scaling up the size of the model and the training by 100,000x. When I got this result, I literally thought it was a bug. For the first 3 years of my PhD, I had managed to scale up these models by 100x. I was proud of that work. I had written multiple papers on how to do that scaling. But I knew pretty quickly that all of that would be a footnote compared to just scaling up System 2 thinking. So based on these results, we redesigned the Poker AI from the ground up. Now,
This clip is particularly compelling because it challenges the conventional approach of scaling AI models to achieve better performance. Noam Brown's insight reveals that by simply allowing an AI model a brief period of del- deliberate reasoning, just 20 seconds, the performance boost can be as significant as what we'd expect from scaling the model's size and training duration by 100,000 times. This suggests what that enhancing an AI's reasoning capabilities can lead to more efficient and effective models without the need for extensive computational resources. It highlights a pivotal shift in AI development, emphasizing the value of quality reasoning over sheer quantity in model parameters and training data.
Reasoning like this.
Yeah, LLMs struggle with logical reasoning because of something called token bias.
I'll take a note on that.
Ah, thanks. Now, remember, these systems are effectively predicting the next word, or more accurately, the next token, in a sequence. And the reasoning output of the model changes when a single token of input changes, which means that tiny little tweaks in how you prompt an LLM with a question can have an outsized effect on the reasoning presented in the output.
So I suppose this is a bit like autocomplete on steroids. If I say, Mary had a little lamb, its fleece was white as...
I'm going to say the autocomplete on that is snow, Jeff.
Well, no. According to the autocomplete on my phone, it's Mary had a little lamb, its fleece was white as a little lamb.
Huh?
Yeah, kind of unimpressive. Well, what would cause such a thing?
Well, the autocomplete uses a predict
Reasoning.
When I first started using AI, I didn't really think about how it was choosing what to say. I just typed in my question and hoped for the best. But after watching this clip and learning about token bias, it totally changed how I looked at AI interactions. It turned out these models aren't actually trying to give you the right answer. They're just predicting what token comes next based on patterns in their training data. That small detail made a huge difference for me. Once I realized that, I started experimenting with my prompts, changing the phrasing, being more specific, and instantly starting getting better results. Now I feel like I actually understand the tool I'm using instead of just hoping it works, whether it's for school, coding, or even something simple like planning. This idea of token bias helped me unlock way more of the model's potential. That's why this clip stuck with me. It's a reminder that just understanding one piece of how AI works can level up how you use it across the board.
significant LLM reasoning improvements through something called chain of thought prompting.
Right, I've heard about that. That's where you append things like think step by step to the prompt, and that encourages the LLM to include reasoning steps before coming up with an answer.
Exactly right. But the emphasis is on the person writing the prompts to use the right magic words, the right incantations to get the LLM to adopt a chain of thought process. What new models are doing is inference time compute. It effectively tells the model to spend some time thinking before giving you an answer. The amount of time it spends thinking is variable based on how much reasoning it needs to do. A simple request might take a second or two, something longer might take several minutes. Only when it's completed its chain of thought thinking period does it then start outputting an answer.
Basically, think before you speak.
Indeed. And what makes inference time compute models interesting?
This is one of the most useful techniques I've come across while using AI. There have been so many times where I was stuck, whether it was on a coding bug, a logical problem, or something school related, and just telling ChatGPT to think step by step completely changed the outcome. This chain of thought style prompting forces the model to slow down and work through the logic instead of jumping straight to an answer. And what's really cool is that it doesn't just help the AI, it helps me understand the problem better too. It's like watching someone walk through a tough puzzle out loud, and it gives you a clear picture of how to approach it. What I love about this clip is how it shows the real power of prompting techniques. You don't need a bigger model or fancier tool. Just ask the right way makes a huge difference. For me, chain of thought prompting isn't just a trick, it's something I've relied on countless times to get through the hard stuff.
Represents the current state of the board. White moves next, and there's a branch for each possible move, from the top left to the bottom right. Black goes next and introduces more branches, and so on. Each path down the tree represents one sequence of moves. We only have time to explore a few of these paths. Which ones should we choose? AlphaGo uses two strategies to prune the search. First, it uses the expert policy we just trained to prioritize the most promising branches. These moves all have high probabilities. Second, it uses the value function to limit the depth of the search. The value function provides a likelihood of winning without simulating the entire game. You might ask, why search at all? Just choose the move with the best value function from the root. The answer is that the value function is only an approximation. It may not be accurate. So you're better off doing as much search as you can afford.
This is one of the most useful techniques I've come across while using AI. There have been so many times where I was stuck, whether it was on a coding bug, a logical problem, or something school related, and just telling ChatGPT to think step by step completely changed the outcome. This chain of thought style prompting forces the model to slow down and work through the logic instead of jumping straight to an answer. And what's really cool is that it doesn't just help the AI, it helps me understand the problem better too. It's like watching someone walk through a tough puzzle out loud, and it gives you a clear picture of how to approach it. What I love about this clip is how it shows the real power of prompting techniques. You don't need a bigger model or fancier tool. Just ask the right way makes a huge difference. For me, chain of thought prompting isn't just a trick, it's something I've relied on countless times to get through the hard stuff. Thank you everyone for watching. I'll see you guys in the next video.